microprocessors and microcontroller subject. I'm Dr. Lachiradi, working as professor in IC department, Lucky Reddy Baladi College of Engineering, Malur. So we'll be discussing about the microprocessor and microcontroller subject. The first unit is microprocessor architecture and instruction set. So microprocessor is a single chip IC, is an electronic device which is a programmable one. It accepts the binary information as input and processes that binary information and produces the result also in the form of binary. So it is having ALU, control unit and register set. So that is why it is also called as central processing unit. So this microprocessor is a programmable device. So as per the program or assembly language instructions, so it does the processing of information. Next, evaluation of the processors. So the first processor developed by Intel is 4004, which is a 4-bit microprocessor having the 10-bit address bus. So with 10-bit address bus, approximately it access the 1 KB of memory and released in 1971. This is fabricated with 2300 transistors and the clock speed is 108 kilohertz. So later in 1972, Intel has released the second version of microprocessor, which is 8008, is a first 8-bit microprocessor having 3500 transistors and functioning with 200 kilohertz of speed. So it is having the address bus of 14 bits and data bus of 8 bits. With 14-bit address bus, it can access up to 16 KB of memory. So next version is 8080. This is released in 1974 with 6000 transistors. It is implemented and it works with 2 MHz clock frequency. Address bus is 16-bit, data bus is 8-bit. So with 16-bit address bus, it can access up to 64 KB of memory. So this disadvantage of 8080 is it needs 3 different power supplies to function properly. So because of that, Intel has released the next version of 8-bit processor, which is 8085 in 1976, implemented with 6500 transistors, and it operates with a frequency of 3 MHz. So the biggest advantage of 8085 is it works with single 5 volts power supply only. So because of that, commercially this is the most successful processor from the Intel. It uses 16-bit address bus and 8-bit data bus. With 16-bit address bus, can access 64 KB of memory. The next, Intel has released in 1978 first 16-bit processor 8086, which is implemented with 29,000 transistors, and its initial operation, it is the clock speed of the 8086 is 5 MHz, but exactly it is 4.77 MHz. It uses 20-bit address bus and 16-bit data bus. So with 20-bit address bus, it can support 1 MB of memory. But at the time of 8086 release, but all the supporting devices with the processor are of 8-bit kind, 8-bit size only. So as a result, there was a biggest problem in the interfacing of the 8-bit devices with 16-bit processor 8086. As a result, so Intel has released the next version of processor in 79, which is 8088. So this is similar to 8086. Only thing is external interface is only 8-bit. Internally it is 16-bit. So with the 20-bit address bus. So also supports 1 megabyte of memory and operates with 5 MHz clock. Here Intel has released 3 versions in 8086. That is 8086, which is 5 MHz clock frequency, 8086-1, which is a 10 MHz clock frequency, 8086-2 operates at 8 MHz clock frequency. So 8086 is being fabricated with pipelining architecture. So that is the difference between 8085 and 8086. And the next version of Intel processor is 80286, released in 1982 with 1,34,000 transistors. It is implemented and operates at the frequency of 8 MHz. Its bus size is 24 bits, address bus size is 24 bits and data bus size is 16 bit. With 24-bit address, it can support 16 MB of memory. And the difference between 8086 and 286, both are of them are 16-bit size, but the difference is, so 808 286 support the virtual memory concept, whereas 8086 doesn't support any virtual memory concept. So that is the difference. And after that, so Intel has released the next version of microprocessor, that is 80386, which is a 32-bit processor, operates with 16 megahertz initial frequency, so up to 33 megahertz, and the number of transistors used in 80386 microprocessor is 2,75,000 transistors, released in 1985. So again the same problem, the peripheral devices are of 16-bit only, but the processor is of 32-bit. So as a result, Intel has released 386 in two different versions, that is 80386DX and 80386SX. So 80386DX is of 32-bit size, and whereas 80386SX is a 16-bit processor. So that is the difference. And compared to 286, the difference with 386 is, so cache memory concept is introduced in 80386, whereas no cache memory concept in 80286. So external cache memory can be connected with 386 processor. Between the processor and RAM, the fast SRAM is being used as the cache memory to improve the performance of the processor, that is 80386. Next version is 80486, released in 1989, implemented with 1.2 millions of transistors and initial operating frequencies of 25 megahertz. So both the data bus and address bus is of 32-bit size, so it can support the memory of 4 gigabytes. Now the 386 also the 32-bit processor with 4 gigabytes of memory support. 486 also same. So the difference is, in 80486 internal cache memory is included, 8 KB of internal cache memory is included in 486, whereas in 386 it is not having any internal cache memory. And another difference is 80486 is implemented with the built-in coprocessor, whereas up to 386 no coprocessor is built into the processor. So if at all we want to use any coprocessor, for example with 386 the coprocessor is 387, for 286 the coprocessor is 80287, for 8088 or 8086 the coprocessor is 8087. So that is, so mainly the coprocessor is used for processing the numerical data. Large amount of numerical data is being processed by the coprocessor, for example floating point data. So that is the biggest advantage of 486, because it is coming with built-in coprocessor and built-in internal cache memory of 8 KB. So and it is released 1989. The next version of 8086 Intel processor is Pentium processor. Instead of giving the number 80586, so Intel has named it as Pentium processor, released in 1993, implemented with 3.1 million transistors and initial operating frequencies of 60 megahertz. So data bus size is of 32-bit or 64-bit, but address bus is 32-bit. So 4 gigabytes of memory it supports. And the difference between 486 and Pentium, because both are 32-bit size, but the difference is Pentium is having internally 16 KB of cache memory, 8 KB for program and 8 KB for data, whereas 486 same 8 KB is used for both program and data, but in case of Pentium, so 8 KB separately for program and another 8 KB separate for data. That is the difference, and coprocessors are built in from 486 onwards. Later Pentium has released, Intel has released the next version of processor, Pentium Pro, which is again 32-bit or 64-bit data size, but the address size is increased to 36 bits. So with that 36-bit addressing, 64 gigabytes of memory it supports. So now the present systems are using approximately 16 gigabytes of memory. So from a Pentium Pro onwards till now, all the processors released by Intel is having 36-bit address size and data size is of 64-bit. So the 36-bit address size is not increased because, so still So no personal computer is using the 64 gigabytes of RAM. So that is why, so the designers or developers are not concentrating on increasing the number of address lines. So there's Pentium Pro, Pentium 2, Pentium 3, Pentium 4, all of them are 36-bit address and 64-bit data. So with 36-bit address, so total amount of memory it supports is 64 gigabytes. After Pentium 4, Intel has released the next versions of processors as i3, i5, i7 and i9. So they are with billions of transistors, implemented with billions of transistors, and operating frequency is approximately 3 gigahertz present processors. Okay, that is, so different versions of the processors used. So now i3, i5, i7, i9, they are multi-core processors. Up to Pentium 4 only single core, but whereas later after Pentium 4 the processors are multi-core, so parallel processing is being achieved with this multi-core processor. That is about the different versions of processors developed by Intel. So today I want to discuss up to now. Thank you all of you.